All right, Department of Engineering Fundamental of the Handbook, Department of Energy Fundamentals Handbooks, Engineering Symbology, Trends, and Drawing, Module 6, Engineering Fabrication, Construction, Architectural Drawings. Table of content, list of figures, list of table of reference, objectives, engineering, fabrication, construction, architectural drawings, introduction, dimension drawings, dimension tolerance, symbols, rules, convention, summary, engineering, fabrication, construction, architectural drawings, examples, example 1, 2, and 3, summary. List of figures, example of fabrication drawing, example of the construction drawing, example of the architectural drawing, type of dimension, line and type of dimension, notation, symbology for the tolerance drawing, example of the tolerance symbology, example of the tolerance, examples 1, 2, and 3. List of figures, table of figures, none, reference. Dimension, tolerance, graphic symbols, electrical, electronic diagrams, digital, troubleshooting, engineering, drawing, design, handbook, logical circuits, logical design with integrated circuits, naval auxiliary machinery, reading schematic symbols, standard graphic symbols, summary, Westinghouse pressurized water reactor, and valve selection handbook. Term objective, given the engineering, fabrication, construction, architectural drawing, read and interpret the basic dimension, tolerance, and symbology, basic fabrication, construction, architectural symbology, enabling objectives. State the purpose of the engineering, fabrication, construction, architectural drawing, given the engineering, fabrication, construction, architectural drawing, determining on specified dimensions of the objects, given an engineering, fabrication, construction, architectural drawing, determining the maximum, minimum dimensions of the location of objective and feature from the stated drawing tolerance. Left intentionally blank. Your engineering, fabrication, construction, and architects, engineering, sorry, what were they again? Fucking EO. Enabling objectives. 1-1. State the purpose of engineering, fabrication, construction, architectural drawing. Enabling objectives 1-2. To give the fabrication, construction, architectural drawing, determine the specified dimension for the object. And enabling objects 1-3. Given the engineering, fabrication, construction, architectural drawing, determine the maximum, minimum dimension, location, object, and feature for the state of the drawing tolerance. The introduction. The chapter will describe the engineering, fabrication, construction, architectural drawing, the three types of drawings that represent the category of drawings commonly referred to as blueprints, fabrication, construction, architectural drawings differ with the piping and instrument drawings. Piping and instrument drawings, electrical prints, logical drawings, and their drawing and scale to provide with the component of the physical dimension as part of the component structures can be manufactured and assembled, although fabrication construction drawings are represented with the separate categories. Both supply information about the manufacture assembled with the component and the structure. The only real difference between the two of the subject matter of the fabrication drawing provided with the information on how the single part of the machine fabricated with the machine shop, when the construction drawings provided with the constructional assembly of the large multiple component of the structural systems. Fabrication drawings are also called machine drawings, the principle found within and around machine fabrication shops where actual machine work is performed. The drawings usually depict the part in a complete component orthographic projection. See Module 1 for the definition of viewing, each of the viewing containing the necessary dimension. Figure 1 is an example of the fabrication drawing. In this case, the drawing is in center of resting U with the support material as being machine. Alright, this shows the fabrication drawing of a centering rest. Shows the different base plate, rest, clamp, adjusting nut, clamp, screw, clamp handle, maximum cap screw, and logic key. Construction drawing are found principally at the site of the construction of the structure system being performed. These type of drawings usually depict structure systems, portions of structure systems, and as an orthopedic projection. Each view containing the necessary dimensions required for the assembly. Figure 2 provides an example of the construction print of the section steel roof truss. This shows the dimension lines over the truss of the steel roof. Architectural drawings used in architecture concept the design, building, structure of the drawings do not provide detailed information on how the structure of the building is built, rather to provide information on how the designer wants to build the appearing and how it will function. Example of the location, size, and type of the doors, windows, rooms, flow of the people, storage area, location of the equipment. The drawings can be represented with several formats, including the orthographic, isometric plane, evaluations perspective. Figure 3 provides an example of the architectural drawing of the county library. Figure 3 is an example of an architectural drawing of a county library. Figure 84, page 84, are dimension drawings. For engineering, fabrication, construction, architectural drawing to be valued, the exact information concerning the various dimensions and tolerances must be provided with the drawing. The drawings usually denote the dimension tolerance of the American National Standard Institute standards. These standards explain the detailed dimension tolerance in ANSI Y14F and M, the 1982. The section will review the basic methods of denoting the dimension tolerance of the drawings per ANSI standard. The dimension on the drawing can be inserted in one of the two ways. The first method, the drawing after the scale, the measurement of the obtained the measurement, the drawing, and the correcting the scale. The second method, the actual dimension of the component was specified on the drawing. The second method is preferred method because of the reducing the changes in error allows the greater accuracy of the dimension drawing flexibility because of the simplest component. Several dimensions must be stated. Each of the dimensions must have the tolerance for the drawing of the quick and quickly become a cluttered dimension that reduce the problem. The ANSI standard provided with the rules convention of the dimension drawing. Basic rules and convention must be understood, but before the dimension drawings can be corrected readily read. Alright, these are dimension tolerance and symbology rules and convention. The actual dimensions are specified on the print. Basic line symbols are illustrated in Figure 4 as are illustrated. A visual outline, full line, shows the shape of the part of the invisible features. The hidden line shows the hidden features of the objects, which is used in a dash line. A center line uses a large dash, small dash, so use locate center of the holes and bounded features. A extension line is a small extend the object lets you know the dimension line. The dimension line has two arrowheads in both directions. Used to show the objective. The cutting plane lines is a mix between a hidden line. It shows the part of the cutaway, which is two arrows on a perpendicular plane, which are make a cutaway section, and the sectioning lining is a diagonal line showing that the part of the object is not visible, that it was being sectioned. Alright, Figure 5 provides examples of various methods used as drawings to indicate linear and circular angular dimensions. Decimal and inches show the different the ways you can arrange the dimensional lines and application of the dimensions, grouping dimensions and angular dimensions, and also circular dimensions. When the drawing the dimension, each dimension must have the tolerance to indicate that the tolerance is not stated, but it is set and implied. But the standard example of the blueprint for the house of the measurement is not only used to give the said tolerance, but it's implied that these carpenter will build the building to the normal inch tolerance of the trade, 1/8 of an inch to 1/8 and 1/4 of an inch. The design using the blueprints allowing the kind of error and another method of the expression of the tolerance of drawing is stated with the title block and note in the global tolerance of the measurement of the drawing. The last method is the state of the tolerance for the specified dimension for the measurement. This method is usually used in conjunction with one of the two tolerance methods. The type of notation is commonly used for the dimension for the requires higher level of accuracy for the remainder of the drawing. Figure 6 provides several examples of how this type of tolerance notation can appear on the drawing. Tolerances are applied with the more than just the limited linear dimensions, such as 1 plus or negative tenth of an inch. They can apply the dimensions, including the radius degrees out of the round and the allowable out of the square surface of the condition, any other parameter that affects the shape and the size of the object. The type of the tolerance is called with the geometric tolerance. The geometric tolerance is state the maximum allowable variable of the form, the position for the perfect geometry implied within the drawing. Determine the geometry for the various forms, such as the plane, cylinder, cone, the square, the hexagon. So theoretically, they are perfect forms because it is impossible to produce perfect forms that necessary to specify the amounts of the variation permitted. These tolerances specify either the diameter width of the tolerance zone within the surface of the axis, the cylinder hole, but it must be in part as meeting the required accuracy of the proper function and fit. The method of indicating geometrical tolerance means that the geometrical characteristic symbols are shown in Figure 6. Example of tolerance symbology is shown in Figure 7. Figure 6 shows the different geometric symbol of the used intolerance dimensions. A straight line, a parallelogram, flatness, circular roundness, circle, cylindrical, a circle with two parallel lines on touching the ends. From individual related features as a type of profile line is a convex line, and for context with a semicircle for polar profile surface. Angle is an angle. Perpendicular is a straight line. Perpendicular parallels is parallel. Position is a circle with a cross through it. Concentricity is a double circle. Circle round out is a circle with a small dot or point with a arrowhead to it. Total round out, two arrowheads with a point to one to it. The arrowheads may be filled in. Term all maximum material condition M, regardless of the feature size S, at least the material condition L, project tolerance P, the diameter circle through the dash through a spherical diameter through the circle and S, radius is mixed with an R, cylindrical radius SR, reference is in parentheses, and arc length is a arc. Figure 10 shows an example of the tolerance. This is basically, it shows the different radiuses and circles looked out with the dimension signs on it, and the cutting section angles, both top and left A side and B, C and C side. Both tolerances allow the part of the placement of the part of the feature to vary hang with the range with all the object dimensions can be specified. This allows the unspecified, therefore the non-tolerance dimension to be absorbed. The error of the critical dimensions is illustrated in Figure 8A. For example, the internal dimensions plus each of the dimension maximum tolerance is added up to the more than specified overall dimension maximum tolerance. In this case, length of each of the step plus the maximum tolerance of 1/10th of an inch from maximum objective length of 3 3/10ths of an inch. However, the image drawing specified the total length of the object cannot exceed 3 1/10. The drawing dimensions of the manner and design correct. One of the following changes must be made in the part of the column correctly manufactured. To prevent the type of the conflict, the designer must either specifically different the tolerance for each of the dimension of the length of each smaller dimension plus a maximum error adds up to the value within the overall dimension plus the tolerance, leaving one of the dimensions off, illustrated in Figure 8B for the preferred method. Figure 8 shows examples of tolerances. Figure 8 shows 3 and plus 1 1/10 of an inch, while you have the 3 1/10 of an inch, which may equal 3 3/10 of an inch, and 3 and plus 1/10 of an inch with a two-figure example figure is 1 1/10 of an inch plus or minus 1 1/10 of an inch. Some of the most important information in this chapter summarize the engineering, fabrication, construction, architectural drawing. Summary: the purpose of fabrication is to provide the information necessary to manufacture machine components. The purpose of construction drawing is to provide information necessary to build and assemble the structure system. The purpose of architectural drawing is to provide conceptual information about the building and structure. The chapter review the basic symbology, dimension, engineering, fabrication, construction, architectural drawing. Examples. Is to aid the understanding of the material presented with the module. Practice reading the following prints and answering the question and the answer of the page of the following last request. Figure shows a kind of like a this shows example 1 with the dimensions and graphic view. Figure 2 shows the dimensions. Example 3 another cylindrical. And then answers and questions. Summary: the information of this chapter is summarized below. Engineering, fabrication, construction, architectural drawing exercise. Summary of the chapter review of the material, dimension, tolerance, and engineering, fabrication, construction, architectural design. Concluding material. That's the last of that. So, this was paid for by me, Department of Engineering, Fundamental Handbook, Engineering, Symbol, Printing and Drawing, Volume 2 of 2.